Okay, this is problem 3 from section 5's questions. And this problem is principally intending to test your understanding of bracket notation. Please recall that bracket notation, you've seen it before. It gets written like this. This left side is called the bra. This right side is called the ket. Physicists enjoy being clever. And this is just saying, take this and multiply it against that. Sometimes this is an operator, then it's take this on the left and operate on this thing on the right. Sometimes it's a constant, then you just treat it as multiplication. So in this problem, we're told that we have some wave function that's the sum of a bunch of different wave functions multiplied by their coefficients. And this is the kind of setup we've seen before. You can go back and review it from when we were studying superposition. Right now, nothing's acting on this wave function, so we can just treat it as a lone ket. And likewise, on the right side, nothing's operated on this multiple yet. So we want to find what C of I could be. So we're going to start by multiplying by some arbitrary wave function psi n on both sides. And now, since the sum of C of I is just some constant, we can take it out of the brackets. And this is helpful because this setup right here is something you've seen before when we talked about orthogonality and orthonormality. When we have two wave functions, in different eigenstates, so if I and n are not the same number, this is going to equal 0. They're going to be orthogonal. Whereas if I does equal n, this equals 1, and they're called normal. So this is nice because now the only wave functions we have left are where both subscripts are n, and we can drop this sum on C sub I because the only subscript left is that n. And we've gotten rid of all the orthogonal states from this term, but we can simplify it even further. Psi sub n is just going to be 1. And this is exactly what we were looking for. If you want to find the coefficient on some individual wave function in this kind of superposition, this psi sub n, you left multiply it with the sum of all of the wave functions, right? Psi sub s was just this sum, and that will give you the coefficient.